Question 3 is about coordinate systems, hyperbolas in particular. We are given that the tangent to h at P meets the x-axis at the point A and the y-axis at point B. So this is a hyperbola. So the tangent to the graph at a point, at any point H, would meet the x-axis at point A and the y-axis at point B. So we have to find the coordinates of A and the coordinates of B. So we know that x is c by t and y is x is ct and y is c by t. So dx by dt would be c and dy by dt would be minus c by t square. So this was basically y is c times t to the power minus 1. So dy by dt is minus 1 c t to the power minus 2. So minus c by t square. Therefore dy by dx will be dy by we can write it like this: dy by dt times dt by dx, or dy by dt divided by dx by dt will get minus c by t square divided by c. The c's cancel out and we're left with minus 1 by t square. Now the equation of the tangent we can write this as y minus y1 equals to mx minus x1. In this case y1 would be c by t, so y minus c by t equals to the gradient, which is minus 1 by t square, x minus x1, so the general point is ct, so x minus ct. Now y equals to minus 1 by t x plus c by t plus c by t from here. So y is minus 1 by t square x plus 2c by t. Now we have to find in A1 the point at which it meets x-axis. So at x-axis the value of y would be 0. So 0 equals to 1 minus 1 by t square plus 2c by t. So 1 by t square 1 by t square x. So 1 by t square x equals to 2c by t. So value of x would be 2c by t divided by t square, or you can write this like this. So 2c by t multiplied by t square. So x would be 2ct and y is 0. So the point A would have coordinates 2ct comma 0. For point B is the point at which the gradient the tangent cuts the y-axis. So we know that at the y-axis the value of x would be 0. So y would be minus 1 by t square times 0 plus 2c by. So the value of y would be 2c by t. So point B would be 0 comma 2c by t. Now in part B, we have to find the area of AOB. We know the points A, B, and O is the origin. So if we want to visualize this, it would look something like this. So this is part of our hyperbola. Let this point be H. So this is, I'll take this point as H. So this will be the scenario over here. This is point B and this is point A. This is the origin. So this triangle, we need the area of this triangle. This point is A is 2ct comma 0, so 2ct comma 0, and B is 0 comma 2c by t. So this length here will be 2ct and this length here will be 2c by t. So we'll get the area to be half into 2ct into 2c by t. The t's will cancel out and we'll get this half and this 2. So we'll get 2c square. We are given that this area is 90 square units, so we have to find c using that. So this is equal to 90. 2c square equals to 90. So c square is 45 and c is root over 45, which is 3 root 5.